Hey guys, in today's video, we're going to talk about recursive functions. Now, recursive functions are very important in computer science, but at first they may be a little bit hard to understand. So we'll work through some examples together, and hopefully by the end of this video, you are okay at recursion. So let's get straight into it. Now, what is recursion? Well, recursion is a function that calls itself. And these recursive programs are used to solve things that have the same steps over and over and over until you reach a certain point. Now this may not make a lot of sense right now, but let me show you an example and hopefully it'll be more clear. So an example of something that you can use a recursive function for is finding Fibonacci numbers. The Fibonacci numbers are 0, 1, 1, 2, 3, 5, 8, 13, and so on. The pattern here is that you get the next number by adding together the previous two numbers. And it will always start with 0 and 1. Sometimes you may see it start with 1, 1, but yeah, usually it starts with 0, 1. Okay, so mathematically, this function is written as f of n is equal to f of n minus 1 plus f of n minus 2. Now this is what we mean by a function that calls itself, right? The function is f, and you can say n is the input, something that you put into the function. And normally, right, this may tell you like equals 2, right? So now you know that f of n equals 2. But in this case, f of n is equal to f of n minus 1 plus f of n minus 2. So you have to kind of keep going, right? So if f of, actually, let me type this. Let's clear all drawings. If f of n is equal to f of n minus 1 plus f of n minus 2, you still have to find f of n minus 1 and f of n minus 2, right? So f of n minus 1 is equal to f of essentially n minus 2 plus f of n minus 3, right? Or you can say f of n minus 1 minus 1, f of n minus 1 minus 2, and etc. Then you will keep on going. So yeah, let's try to find f of 10 for the Fibonacci numbers. So let's see. So f of 10 is equal to f of n minus 1. 10 minus 1 is 9, plus f of 10 minus 2 is 8, right? F of 9 equals f of 9 minus 1 is 8. 9 minus 2 is 7. Oops. F of 8 equals f of 7. F of 6. F of 7 is equal to f of 6 plus f of 5. F of 6 is equal to f of 5 plus f of 4. It's going to take a while. F of 5 is equal to f of 4 plus f of 3. F of 4 is equal to f of 3 plus f of 2. F of 3 is equal to f of 2 plus f of 1. F of 2 is equal to f of 1 plus f of 0. F of 1 equals f of 0 equals. Okay, so finally we got this all typed out. You can see that this pattern follows f of, say, like f of 10 equals f of 9 plus f of 8, f of 9 is f of 8 plus f of 7, all the way down. Except when you get to f of 1 and f of 0, what do you do then, right? Because if I were to follow this pattern, then this would be f of 0 plus f of negative 1, right? So And as you can see, you can just keep on going and going and going. So there has to be a stopping point. Yeah. Oh gosh. So what do you do after f of 1 and f of 0? Well, the recursion stops, right? So let's move this here. The recursion will stop. And cases when the recursion will stop are called base cases. So for the Fibonacci sequence, the base cases are 0 and 1. It's because, as we know, the Fibonacci always starts with 0 and 1. Doesn't go to negative. So now that we know that base cases are 0 and 1, right? And it says this. So this is the function, right, for the Fibonacci sequence, the full function down here. So we can see that if n is less than or equal to 1, the answer is just n, right? So if f of 1 is just 1, f of 0 is just 0. And then that means f of 2 is 1 plus 0 is 1, f of 3 is 1 plus 1 is 2, f of 4 is 2 plus 1, f of 5 is 3 plus 2, f of 6 is 5 plus 3, f of 7 is 8 plus 15, is 8 plus 8, 8 plus 5, sorry. F of 8 is 13 plus 8, f of 9 is 21 plus 13, yeah, 21 plus 13, and f of 10 is 34 plus 21. All right. And I think it'll be just something cool to see. This is how the Fibonacci sequence may be like coded out in Java. So yeah. All right. Another example is the factorial function. Right? So some of you may know that factorial is basically just the number times 1 less than it times 1 less than it. So basically 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay. So yeah, then how about we try to kind of, how about we try to, oh, okay. How about we try to find 3 factorial. I'll do something smaller this time, right? So f of 3 is equal to, you can see 3 is greater than 0, right? So that means f of 3 is equal to 3 times f of 3 minus 1, which is 2. F of 2 is equal to 2 times f sub 2 minus 1 is 1. F of 1 equals 1 times f of 1 minus 1 is 0. Now you can see that f of 0, x is 0 now, x being this the thing in between the parentheses. F of 0, if x is 0, then the answer is 1, right? So now we have to go back, right? So we found f of 0. Now we can find f of 1, right, by saying f of 0 is 1 time, f of 1 is 1 times f of 0, which is 1 times 1 times 1 equals 1. Now we know f of 1 is 1. That means we can find f of 2 is 2 times 1 equals 2. Now we can say f of 3 is 3 times 2 equals 5. So now we know 3 factorial is 5. Oh no, 6. Sorry, 6, because it's multiplication. Yep. And we can confirm, right? 3 times 2 times 1 is 6. Cool. And then this is the Java implementation of the factorial function. All right, now we'll try some sample problems. And I'll have you guys try this on your own if you can. And if you get stuck, then we'll work through it together. Okay. So problem 1, right? Find g of 11 given the following. G of x is equal to if x is greater than 0, then it's equal to g of x minus 3 plus 1. So otherwise, that means if x is less than or equal to 0, then the answer is 3x. So yeah, try to take a few minutes and pause the video and try to solve this. And now I will go over the answer. Okay, so I put the problem here just so you can see it, but this is the answer, right? So you start from g of 11, and you can see that's greater than 0, right? So it's equal to g of 11 minus 3 is 8 plus 1, right? G of 8 is equal to g of 5 plus 1. G of 5 is equal to g of 2 plus 1. G of 2 is equal to g of negative 1 plus 1. Now you can see that x is not greater than 0, right? So g of negative 1 is just equal to 3x, which is 3 times negative 1, which is negative 3. Okay, so now that we know g of negative 1 is negative 3, we can use this to learn other values, right? So we kind of work our way back up the recursion. So now that we know the value of g of 2 is negative 3 plus 1, which is negative 2, right? And then now we know that g of 5 is equal to negative 2 plus 1, which is negative 1. Now we know that g of 8 is negative 1 plus 1, which is 0. And remember, these are just the previous 1 plus 1, as you can see here. And finally, we have the value of g of 11, which is 0, which is g of 8, plus 1, which is 1. Okay. Now we'll try another problem. Find the value of h of 13 given the following definition of h. So yeah, take a minute to read through this, and pause the video, resume the video if you finish or get stuck. Okay, now we're gonna work through this together. So first, I need to define the problem, right? So h of x is equal to h of x minus 7 plus 1 when x is greater than 5. It's equal to x when 0 is less than or equal to x is less than or equal to 5, right? So basically, h of x is equal to x when x is greater than or equal to 0 and is less than or equal to 5. And h of x is equal to h of x plus 3 when x is less than 0. So I put this problem up here so you can see it. But yeah, let's start the solution. So h of 13 is equal to h of 6 plus 1, because this is the top rule, right? Is h of x minus 7 plus 1. So x is greater than 5. So now h of 6 is equal to h of negative 1 plus 1. This is also the top rule since x is greater than 5. H of negative 1 is h of negative 1 plus 3, which is h of 2. This is the bottom rule since x is less than 0. And h of 2 is just 2. This is the middle rule since x is in between 0 and 5. Okay, so now we found h of 2. Now we have to work our way back up the recursion. So h of negative 1 is equal to h of 2, which is 2. H of 6 is equal to h of negative 1 plus 1, which is 2 plus 1, which is 3. H of 13 is equal to h of 6 plus 1, which is equal to 3 plus 1, which is 4. So h of 13 is 4. All right, next problem. I'll move myself down here. Find the value of f sub 12, 6, f of 12, comma 6, given the following definition of f. F of x comma y is equal to f of x minus y, comma y minus 1 plus 2 when x is greater than y, and it's equal to x plus y when y is less than or equal to x. So again, pause the video to work on it and pause when you're ready. Unpause when you're ready. Okay, now we'll go over the solution, right? So f of 12 comma 6 is equal to f of 6 comma 5 plus 2. This is the top rule. And f of 6 comma 5 is equal to f of 1 comma 4 plus 2. This is also the top rule since x is still greater than y. And f of 1 comma 4 is equal to 1 plus 4, which is 5, because x is less than or equal to y. And this is the bottom rule. Now again, we work our way back up the recursion, right? So let's see. Yeah, so f of 12, so this is another way you can think of this, right? So f of 12 comma 6 is equal to f of 6 comma 5 plus 2 is equal to f of 1 comma 4 plus 2 plus 2 plus 2, because you're kind of essentially taking this plus 2 and putting it here. So f of 1, 4 is 5, and then plus 2 is equal to 9. Personally, I prefer the way that we did it in solutions 1 and 2, but if this way makes more sense to you, then feel free to do this. Okay, we finally made it to the end of the video. Thanks for watching, and I will see you in the next one.